Hi everyone, and welcome to another edition of the Code Remix Weekly. As always, we are your hosts. My name is Tim Beck, and with me is Sam Snyder.
Hello.
And we're going to take you through things that are first new in this past week in OpenRewrite and Moderne. And then from there, we're going to do a deeper look at some of the recipes I had quite a bit of fun with running recently related to feature flags. Yeah, as always, I'll first take you through a couple of tabs of things new in the past. While we haven't yet done a release, we will probably do a release tomorrow. We have been working on a couple of features that you might be interested in. First off, I had a bit of fun writing a recipe that mimics what we already did for Java, but now does so for Node.js applications as well. So if you have dependencies, and those dependencies might have vulnerabilities, you might be interested in servicing exactly that. Especially now that we have data tables to bring that information to you, both from the plugins that we bring in the open source world, as well as the Moderne CLI. You can now
Y-
write this new recipe.
Your volume's a little bit inconsistent, Tim. Like sometimes I'm hearing you full volume and then it's kind of like dropping down to being very quiet, and I'm not sure why.
Let me switch to a device there. So I had it sent to noise canceling because my neighbors have been having some leaks, and I thought it might help.
Ah,
If I'm
well,
dropping out,
it may be that you just need to speak up to cross some threshold for it not to interpret you as background noise.
well, we'll do our best. So
Very
do
good.
keep me posted. So as I said, we already had a recipe to find vulnerable dependencies that you might be using, and we now have one analogous recipe to do the same for Node.js. If you are using the package JSON and a package log.json, we will evaluate those files and give you a visualization of exactly which recipes there might be vulnerable. I can maybe even show you this in a sample application of, let's go for popular JavaScript applications, and then find vulnerable npm repositories. That one. And let's add these to markers just because it's a little more fun to look at the results when we do. But what this recipe, again, will do, similar to the Java analog that we have, is that you can get bumps to the patch versions of dependencies that you're using. So if you are using an outdated version and you should be using a newer version to be safe, we will make a code change for you. And in this case, you can also tell you exactly which vulnerabilities might be out there in the dependency that you're using. In this case, we're not going to bump you because it's a new major version, even actually two new major versions. But we can bring that information to you, and we can also export that to a table for you. So just making the panels you already know and use well for Java applications similarly work for your NPM applications. So quite pleased to have that coverage there. If you go back, you can also see that we can export this to visualizations, and you will get the exact same type of visualization as you would otherwise get for the Java applications, but now showcasing vulnerabilities in the NPM application. Just neat stuff. It was a fun bit to get this working, and pleased to have it. And here you can see that the NPM world is slightly different from the Java world. Whereas in the Java world, you'd have a ton of patch versions that you can bump and fewer minor versions. In the NPM world, there is a ton of major versions that you should be adopting to get off all vulnerable events. So that'll be fun to explore once we build out further support for updating those dependencies and the necessary code changes there as well. So keep an
Nice.
eye out. Should be nice.
Interesting looking at this result. When I run the find and fix vulnerable dependencies on a bunch of Java repositories, and I have no idea how representative this sample you've just run on is, tend to have
Mhm.
most in the patch column, then minor, then major. I guess this is a relatively, maybe it's a small number of results. So I was just surprised, or is it more common in the JavaScript ecosystem perhaps to not do patch releases but only have major and minor releases?
I think we're seeing a difference in how things are structured there. It's
Yeah, that makes
should
sense.
be fun to explore that. Once we have more data, and of course we can export those data tables as well, and you'll get a nice Excel sheet telling you exactly where you have work to do. Pretty good. So that's coming up. Will be in the next release. But if you use the Moderne platform, as you saw me do, you can already try it out there. And similarly, a new recipe that we've worked on, and you in particular, Sam. So maybe you want to highlight this one.
I just realized I was just talking with a customer of ours who would have been interested in this, and I forgot to mention it to them. Oh well, better late than never. Yeah. So
Let's hope they're watching.
yeah, let's hope. Yeah, I mentioned one of them was interested in feature flags, so I made sure to mention to him to check this out. Hi, Nicholas, if you're checking out the recording or, or watching live. But yeah, the idea here is that there is this specification, the Cyclone DX specification for so-called software bills of materials, which is an XML or JSON blob which defines some similar information to what you would see in a Maven POM or a Gradle build file. Things like what the dependencies are, sometimes what licenses those dependencies have, or what vulnerabilities they have. The idea being that this is a standardized format that many different tools could consume in order to produce diagrams or help you to analyze the relationships of your software with each other. And so, if you are using any tools that use SBOMs, Cyclone DSX SBOMs for anything, well, there is now this recipe to help generate those SBOMs for Gradle and Maven projects, and that is in the Rewrite Java Dependencies project, and is creatively named Software Bill of Materials. So check that out if that is something of interest to you.
Yeah, absolutely. And it should be fun because we've had this request come up before. And of course, we did have support for it in the Rewrite Maven plugin, but we didn't
Yeah,
have the parallel in the integrator plugin. And of course, yeah, you want to support both.
yeah. Yeah. This was a somewhat hidden and somewhat hidden feature of the OpenRewrite Maven plugin. Well, hidden enough that I forgot about it. It was not really hidden. I just forgot that it existed. But there is no reason it couldn't just be a recipe, so I made it a recipe.
Mm-hmm. And of course, we are very, let's say, strict in that we only want to have one way to do things. So that Maven plugin option that we had is probably going to be gently coached towards using this exact recipe here.
Totally.
So should be neat to learn. And of course, we'll see this come in within the new release probably tomorrow. So then a new thing that Justine has been working on and is quite neat is that we have, let me try to rerun this instead, rerun the recipe, is that she's been expanding the AI code switch that we have. So of course, with Moderne, we want to be predictable in the code changes that we do. But sometimes you have use cases that allow for a bit more, you want to search something, you want to be a bit more flexible in your in and outputs. And the AI search that we have here is going to allow you to do exactly that. So we have here a recipe, and it allows you to use some search terms. In this case, we want to look for anything that does an HTTP request. And we're going to do some clustering across a bunch of applications that we're going to look over. And then we're going to extract methods which might be similar to that exact pattern. So when we run this, we will schedule this against a couple of sample applications that we have in the platform here. And then from there, we're going to get some results presented here as a diff. But we can also go to a visualization, which I think I have already lined up on an older run as well, where you then get presented with a rewrite YAML recipe that you can then run to find all the instances that we have matched. So if this is going to take a little while longer to run, then I'm going to switch back to those results, where you can see that we have ran that recipe, which produced some results on a number of applications, and we can explore those results. See, indeed, this is doing an HTTP request using the, I think the JUnit, the request contact here. This is doing an HTTP request. But if you are using a larger application, maybe you have different types of libraries that help you do HTTP requests. And with this one recipe, we were able to find them all across various technology stacks and libraries to do those HTTP requests. And then the really neat thing is that we can produce a visualization, or more like a data table. Here, all the various types of methods that we think are related to doing an HTTP request. And what we can then do is take all of these and run a new search across all the repositories that we have, and then have a more structured way to search for exactly those hits. And you'll find that we get more results if we do it in this way than we had previously when we used the AI search, because this allows you to do some sampling, whereas this does a very exact search for all the libraries that we have identified to do something related to an HTTP request. Of course, the results will start to stream in, but we can already see that in this case, we are matching some of those same patterns, but now we are exactly going to match all of them rather than just that sampling that you might have otherwise been limited to. So this is a really neat way to just do code searches. Maybe you're looking for particular HTTP headers or HTTP requests, or maybe calls out to persistence, something that you might be not sure of what you're going to find. But this recipe will then allow you to find that exactly, and then continue on to do more structured searches using those method patterns that you saw identified here. That's really neat. We're going to probably get Justine on pretty quickly once this is all polished up, and then have her explain all the details of how exactly we arrived at doing all of this.
For sure. We'll definitely get Justine on here to talk about this.
Yeah. So that's pretty much all I had in terms of things that are new this week, with the exception of one large new topic that is new this week, and that is the feature flag we're going to talk about now. So some of you might know that we had some support in the past already for finding and searching and finding feature flags using the Launch Darkly SDK, and also to phase out those feature flags using existing recipes. But while those recipes allow you to do something similar for other SDKs as well, it wasn't as neatly polished up. So instead, what we've now done is we've created dedicated recipes for a number of different SDKs that you might know if you work with feature flags, such as easier to find them and easier to help phase out the feature flags as you need to. So if you want to explore that, you can go to the app.ruin.io marketplace, and I'll link the marketplace right here, where you can see the whole category of feature flag related recipes that we have. And from there, I have written a small sample application that I'll take you through to show you maybe a bit of the flow of what we think it would be an effective way of using feature flags in your own application. So I won't demo that using the platform because there's surprisingly little applications out there using feature flags in an open source application. It's more something in an enterprise where you want to be staging the rollout of your features. Whereas, in an open source application, you'll just do a new release and do it. So I'm going to switch to presenting my IDE. And that is going to be the feature flag demo application that I have here. So what I've done is I've written a very quick sample application which just does something with books. It's a go-to example. It's not very special. It has books, they have a title, and they have an author. And you maybe have a controller that allows you to search for a particular query and search across the books that you have and get exactly those matches. So we have a couple of boilerplate services, like a service that has multiple books with some titles and some authors. And we have an alt search implementation, which right now only allows you to search through the titles of this application. And it, of course, already implements an interface. And what we're going to do is we're going to try to find all the usages in this application of this particular search method, where we take in a query and do this search. What we really want to end up with is that we're going to replace those search calls with maybe a different implementation that doesn't just look at the title, but also is able to look at the author name for that same query, just so you get better and more hits based on the same input. That's a bit of a sample application. And from there, we're going to look at some recipes that could help you in this flow of introducing feature flags. And from there, rolling them through the next stages and actually phasing them out once you're done. So the first thing you'll want to do, like I said, is going to find all the instances where we are calling on our search service to do a search for a particular string. And for that, we're going to use this little search recipe that we have. And since this is a very small application, it's good enough to do this directly using the IntelliJ integration for OpenRewrite recipes. And what this will do is it will show us search results as a diff on this particular application. And you can see so that we indeed for this controller have identified that we are calling that search service.search with a query, and it's in this case using the old search service. So this is kind of like your impact scan. Of course, here it's rather silly small example where we only have one case. But if you imagine that you have multiple services across multiple repositories, all calling out to the same search service, then this would help you better judge where you might want to be making changes to swap out one implementation for another. So then let's revert the changes here because we found this one. And what we're actually going to do is we're going to replace that particular usage of that search service with one that gets toggled by the calling out to a open feature SDK to switch between implementations. So we'll remove the old implementation. And now, based on what this feature flag we've introduced, we're going to call on the getBooleanValue method here for the search key that is our feature flag name. And if that is found, we're going to swap between these two implementations. So if it is true and it's enabled, or if we can't reach the SDK provider, then we're going to run the new search. And if it's set to false in the client response, then we're going to still call out to the old implementation. So this is then you'll have to introduce this snippet yourself right now. We've not yet automated this part of the lifecycle of working with feature flags. But we have some recipes to help you with the next phase that you might be interested in. Because if you, like other folks, if you've maybe been using feature flags for a while and you add something here, like a to-do cleanup January 2024, and then you come across your code and you find that this has not been cleaned up. Or you're going to postpone that work to 2025, but in reality, if you have a couple of services and all are using those same feature flags, you might want to be proactive in cleaning out these things, especially when they are a very old feature flag that you're using, something like 2023. Then you'll actually want to do something about it. So the first thing you can do with the recipes that we've developed, and we have those for a number of different providers, is to find any case where you are now calling this SDK using this exact argument feature key. We have a different search recipe here. So if I disable this one, and I enable this recipe, you can find that we can search for, that's not the one I was looking for. Slightly different. Let's do, see what's it called again. Purge. And then I think it's find feature flag. Yes. And we're going to do this recipe. And what I hope to find is exactly this one instance here. And again, have that search marker introduced before we see this here. We're going to run this new recipe. It's going to build up that model of our code, and then if we find any hits, it's going to point them out in our diff here. And indeed, we've seen this snippet introduced by the recipe to indicate to us that we are indeed calling this particular SDK of the open feature method call to find precisely this feature flag. If we were using a different one, then we would not get any hits. So if we remove that again and we do balancing different here, then we should not be getting any hits here after the recipe runs. And similarly, if you just want to find all the instances, you can also just remove the entire feature key, and that will find any feature flags that you might be interested in for this application. So this is a very quick way to just get a better sense of where you are maybe using particular feature keys or feature flags in general across your applications. And you'll see those results by those search markers. And of course, if you're using the Moderne platform, those are visualized slightly better than with the comments that you see here. So then what you can now do is probably you want to get rid of these very old feature flags where you are switching the logic between this implementation and this one. And for that, we have a different recipe that is very similar, but slightly different in that you can now remove this particular feature flag method call. And you can choose to either keep the if side of this statement or the else side by saying that you want to replace this feature flag just by the literal true or the literal false. And what we will then do is run a next recipe that will actually clear out this conditional by removing either this entire block or this entire block, just as we need it. So what we can do is we can demonstrate that by having this method call in there still. And then we're going to run a recipe, which will remove that particular feature. So it will be remove get boolean value. And we're going to find the feature key use new purge service is, I believe, the correct one. Yes. And I'm going to run this one, and we're going to replace it with key value true to say that this one should now be enabled by default. And what we do is if we run this particular recipe, and I'm going to run this and very quickly switch over to this particular class, it should be updating this class to remove this element. And indeed, you see it very quickly just retain the contents of the conditional that we were using, completely stripping out the old implementation that we had before. So that is how we suggest that you use feature flags using recipes to help you find the insertion point where you might want to switch your conditional logic. Next up, introduce that conditional logic. And then sometime in the future, find where you are using particular feature keys. And again, run and expect the recipes to actually clear out those conditionals and just be left with the patterns that you actually want to be using instead. That's, I think, a fairly quick overview of how you could be using these patterns. And like I said, we have this implemented for a number of different SDKs. I can show you that right here. Through a different tab, where if you go to the rewrite feature flags repository that we have, you can see that we have this implemented for the SDKs from feature flag 4J, where we have a search recipe and a remove check, where it's just if you look towards the tests here, you can see that you'd be replacing these types of patterns with the ff4j and replaced with just retaining one part of the conditional. And similarly, we have this, of course, still for launch darkly, where their SDK is slightly more verbose, but we're still able to clear out those patterns for you. We also have it for open feature, as you saw me do in the demo. We're able to clear these out. And then the final one is that we have it for Unleash, where you're also able to do these types of replacements. Now, we've had some customers report to us that they are not using the direct SDK from a particular vendor. They're instead having it wrapped within their own wrapper classes that have a similar type of signature. And for that, we have a generic recipe, the remove boolean flag recipe, which takes in an argument method pattern and also a replacement value and a feature key that you could use to maybe replace any internal feature flag like recipes that you're using. So in this case, you just give it a method pattern which you already know if you've developed some recipes in the past, which will match exactly this particular method in this case. And from there, do the same type of replacements if you see me do, but now using whatever internal library that you've developed around maybe a different SDK. And then we can do the same, and we're quite smart in how we are going to detect those feature keys. They don't always have to be a literal. They can always also be part of a field or maybe a variable that's being used. And all of that will be cleared out and just retaining the part of the application code that you actually want to keep. So that's pretty much what we've been having a bit of fun developing over the last couple of days. And of course, we hope that you take from this that if you are you want a different SDK developed still, that you can see these patterns and how we would easily add that still. And of course, if you want to do other kinds of operations on these SDKs, like upgrading from one version to the next, or maybe switching between implementations, maybe switch towards the open feature standard for your feature flag, then the rewrite feature flags repository would be the place to add it. So that's a very quick view of what we think would be a helpful flow to use with feature flags. So I hope you've enjoyed that.
Yeah, I wonder if just how good Justine's AI recipe is at identifying feature flagging sites. That strikes me as another possible use here.
That would absolutely, I think, be a very good use case to find exactly other SDKs that might be feature flag like, and from there see how we can move those over to phase them out and remove them. So that is pretty much it for updates that I have for this particular week. I'll give you a quick look ahead to next week, where we'll be talking to Marit van Dijk, a good friend of mine who is a Java champion and developer advocate at JetBrains, where we'll be going over some of the features of using and developing OpenRewrite recipes using the IntelliJ IDE, and maybe contrasting that with our own plugin that we have at Moderne to help you develop new pre-faster and imperative style recipes using that as well. So, looking forward to that. I know, Sam, you're looking forward to a nice holiday to Europe. So,
Yeah, maybe I'll get to see you in Amsterdam soon.
Absolutely, yeah. We'll check that for that lunch on Monday, and then so sad to not have you with us next Wednesday, but at least you'll be enjoying yourself quite well, I suppose. So then, that's it for this week, I suppose. Unless there's anything you want to add before signing off.
No, yeah. Have a great week, everyone.
Yeah, thanks a lot for showing up, and I hope to see you soon. Thank you.